In the last lesson, we focused on solving inequalities just by adding or subtracting. In this lesson, we're going to extend this so that you can solve inequalities by multiplying or dividing as well. So go ahead and write down that learning target. Try the 3 warm-up questions you see there that are just a review for Chapter 2, and then hit play when you're ready to resume. So for the warm-up questions here, for number 1, we're going to divide by 5 on both sides. Opposite of multiplying is dividing, so a equals 6. Number 2, that's y over -5, but you can also say y divided by -5. So the opposite of dividing by -5 is multiplying by -5. 3 times -5, remember a positive times a negative, that means you have 3 groups of -5, that's -15. Number 3, we're multiplying x by -3/4. We're going to divide by -3/4 on both sides. So you can see in the second line of work there, what I did was I did my multiplying by the reciprocal, or as some of you learned it, keep, switch, flip. Make sure you know multiplying by the reciprocal, because that's the big boy, big girl way of saying it. So we've got 6/11ths there. We're just going to change it to multiplication, and then the reciprocal of 3/4 is 4/3. You can see also, it's a little small, but you can see I simplified the 6 and the 3. I can do that because of the commutative property. 6 becomes a 2, 3 becomes a 1, and then you have -8/11ths. For Chapter 3, again, just like in the last lesson, solving these is done the exact same way. Whatever is happening to the variable, in this case we've got coefficients, we do the opposite operation to solve it. So how is this going to be different with inequalities? Well, there is one slight difference. And you can see there on your notes, what changes when your inverse operation is to multiply or divide by a negative? Well, we switch the direction of the inequality. Remember, some of you remember that as the special rule from last year. Let's talk very briefly about why that is the case. So let's say we had the inequality -10a is less than 20. Well, to solve this, I divide by -10, right? So a, if I didn't switch the inequality sign, notice how we divided by a negative, so -2 is going to be like the gate between what works and what doesn't work. If I left this as -2, so this would be saying that solutions for a are all the values that are less than -2. Well, pick a value like -3, see if it works. Well, if I took -3 and I plugged it in for a right here, watch what happens. Switch colors. So if I did -3, -3 is a value that's less than -2. So it should work not only if I plug it in here at a, but it should also work if I plug it in back here. So if I do -10, let me make sure that I erase this, give myself more room. If I did -10 times -3, if -3 is a solution, that should be less than less than 20, right? Except notice what happens. -10 times -3 is 30. 30 is not less than 20. Well, think about what happened here when I solved. When I solved, I was on the positive side of the number line at 20, right? But then when I divided by -10, I flipped over to the negative side. So watch what happens to my solutions. Notice my solutions are not the numbers that are less than -2. What if I took a number that was more than -2? Let's say I took 1, or negative. Let's do -1. So if I do -10 times -1, that's got to be less than 20 for this to work, right? So I've got 10 is less than 20. Notice how things that are less than -1 end up working, okay? So this doesn't work, but when I flip the inequality sign like I'm supposed to, when I say a is greater than -2, just like this rule over here says, then I get solutions that work. So that's the only little change you have to remember there, that special rule. If you multiply or divide by a negative, you have to flip the inequality sign. Okay, so let me erase all this here. You can write that down if you want, but we need a little bit of space here. Okay, let's zoom back out. Okay, and I'm going to cover this up for now. Okay, let's go ahead and talk through numbers 4, 5, and 6, and then you're going to try 7 and 8 after that. So number 4, we're going to solve and graph these. We divide by 5 on both sides, and we get a is less than 6. Okay, so think open dot or closed dot. This is an open dot because it's not less than or equal to. And then what works? Well, did I divide by a negative? No, I did not, so I don't have to flip the inequality sign. If I think about numbers that are less than 6, that would be like 5 and 4 and so on. And indeed, if I plug in 5 into here, notice how 5 times 5 would be 25. That's less than 30. So all the values less than 6 work. So that goes out that way, like that. Number 5, if I want to solve this one, notice how we are dividing by negative 5, so we must multiply by negative 5. This gets to that question you see over here. What's the difference between 5 and 6? Well, hit pause. Let's kind of come back to number 5 here. Here I've got y divided by 5. Now notice here, and that's greater than negative 3. Notice how 6 says y divided by negative 5. So here I got the negative down here in the denominator. Here I've got the negative on the other number on the other side of the inequality. So when I go to solve the, number 6, notice I multiply by 5. The rule has to do with what we multiply by. On number 6, am I multiplying by a negative? No, I'm multiplying by a positive, whereas in number 5, I'm multiplying by a negative. So number 5, we have to flip that inequality sign. And number 6, I still get negative 15 over here, right? But because I multiply by a positive, it stays as greater than. Okay, we need to close, both of these go at 15. Okay, I need a closed dot. This one is going to go toward, oh wait, it's negative. My bad. Okay, there we go. This one is less than negative 15, so that would be toward negative 16. On here, again, we're at negative 15. But now we're greater than negative 15, so we're going to go back this way because those are the numbers that are greater than. Again, the difference between those two is what we're multiplying or dividing by. Okay, so don't cheat. I know you can see it, but hit pause, try these on your own, and then resume when you're ready to check your answer. Okay, so 7 and 8, pretty straightforward. Number 7. Got to divide by 5. Notice we are not dividing by a negative, so we don't flip the inequality sign. So we have negative 10 is less than or equal to q. So that would be negative. Oh, I got my arrow going the wrong way. I caught my mistake. Always check for errors, ladies and gentlemen. So q to negative 10 is less than q. My mistake was I just followed the direction of the inequality. We talked about that in the last video. Here, I would go toward, maybe I'll number that negative 9. I would not have enough coffee yet this morning. I'm going to go toward negative 9 because those are the numbers greater than negative 10. Negative 9 would work if I plugged it in for q. Negative 11 would not. Number 8 is kind of like number 3 on the warm-up. We're dividing by 3/4, so notice how I multiplied by the reciprocal right here. Switch that to 3/4. There's no negatives in this one, so it just stays greater than, and it's an open dot. Okay, taking a look then at number 9. Ryan has a $24 gift card. So think about what that means. That means he has $24 that he can spend, and a pie is $3, so that's $3 each. What are the possible number of pieces of pie? A piece of pie is $3 each. What are the possible number of pieces of pie that he can buy? That's our unknown. So we're going to say P is represents number of pieces. Okay. So think about the inequality here. Think about, remember, inequalities are comparisons. The comparison here is how much Ryan actually spends if he's buying $3 or he's paying $3 versus what he could spend. He could spend $24. Could he spend more than that? No, he doesn't have that amount of money. Could he spend less than that? Yes. So we're looking at a comparison between what he actually spends versus what he could spend. What he could spend is this $24. What he actually spends is $3 for each piece he actually buys. So if it's $3 each, that means he's going to pay $3 repeatedly, multiple times. So that's 3 times P. On the other side of the inequality, we've got this 24. Again, this 3P is what he actually is going to spend. That cannot be more than 24. It has to be less than. It's no more than. Now, could it equal 24? You betcha. So we've got less than or equal to 24. Now, to solve, divide by 3, and you get P is less than or equal to 8. No negatives there, so I don't have to flip the inequality sign. When I graph this, there's 8, there's 7, there's 9. We've got a closed dot on 8, right? And then I could buy 7. So think about the solutions. The solutions here would be 0, 1, 2, 3, 4, 5, 6, 7, and 8 pieces. You wouldn't go less than 0. So if we wanted to be totally accurate on this, we'd extend the number line all the way to 0, and this wouldn't actually be a ray. It would be a line segment. Okay, let's look at a couple closer questions here. All right, here's our solution. We did this in the last one. What could we do to both sides that would get us, or what inequality could we have that would get us this this equation here? So go ahead and pause the video, try this yourself. All right, I'm gonna make this a little difficult. So let's say I used a negative. Let's say I had negative 4x. Well, to get a positive 7, I would have to have, notice how I'm going to divide both sides by negative 4 to solve this thing? Well, if I divide by negative 4, I would have to divide negative 28 by negative 4, okay, because that would give me positive 7. Now, I'm going to also pay attention to the inequality, because if I divide by a negative, I would need to flip the inequality. So that means I'm starting with greater than, and then I would flip to negative 7. You could have done something a lot easier than that, but that's just what I was thinking. Last question, is there a transitive property? Transitive property says if A is equal to B, B is equal to C, then A equals C. Is there a transitive property of inequality? So think about, pause the video, think about what that might look like, and then hit resume when you're ready to look through, talk about the answer. So the transitive property would be like if A is greater than B and B is greater than C, then A is greater than C. It would look like this. Okay, so let's throw some numbers in there just to see if we can have some examples. Well, if I've got, let's say A is 6, okay, well, let's choose a number for B. Well, I could say 6 is greater than 5. And then, so if B is 5, well, is there a number that 5 is greater? Yeah, let's pick 4. Well, notice how A, which was 6, is certainly greater than C, which is 4. So according to our example here, there is a transitive property of inequality. And that's all for that lesson. Go ahead and use this. Don't forget about that special rule, though, back on the first page there. If you multiply or divide by a negative, flip the inequality sign. When you're done with the homework, turn it in. Make sure you make your corrections. Go ahead and move on to the next lesson.